Hello students, now today we will discuss regarding the structure of atom. Structure of atom is a unit. So first topic is discovery of electron, because discovery of electron takes place through discharge tube experiment. Before I will give you a brief idea regarding the discovery of electron, first of all you should know about what are the subatomic particles which are present in atom. Basically, atom is a smallest or tiny particle of substance or matter which consists of, which contains subatomic particles, proton, electron, and neutron. So here in this unit we have to explain, we have to be study here discovery of electron and discovery of proton. Both are based on discharge tube experiment. So I will start here discovery of electron. Discovery of electron takes place. Discovery of electron was given by J.J. Thomson. J.J. Thomson. So J.J. Thomson used discharge tube, which is basically a William Crookes tube, which is used in physics. So J.J. Thomson uses discharge tube experiment which gives the discovery of electron. So discovery of electron takes place discharge tube experiment, or you can say cathode ray discharge tube experiment, because cathode rays are generated from cathode which moves towards the anode. So it is based on, so it is also known as cathode ray discharge tube experiment. So how discovery of electron takes place, how discovery of electron takes place, how it can be discovered. So it is based on cathode ray discharge tube experiment. First of all, let me first here explain what is discharge tube. Discharge tube is simply a tube which is made up of glass where vacuum pump is used. What is the use of vacuum pump? Vacuum pump actually evacuates, vacuum pump actually here removes the gases, removes the air which is present in discharge tube experiment, because there will not be produce any kind of error in this discharge tube experiment, so that discovery of electron takes place easily. So how discovery of electron takes place? First of all, we have to explain here construction. So what is construction? Here is a tube which is discharge tube experiment. This is a vacuum pump, and these are the cathode. This is the cathode, this is the anode. Cathode, the cathode develops cathode rays which moves towards the anode, and here is plus, that represents anode, here is negative, that represents cathode. And cathode and anode, they are connected to a battery which applies high voltage. High voltage means at least 10,000 volt. 10,000 volt energy is to be applied. When 10,000 volt energy is to be applied, certain conditions are to be required here in order to discover electrons. Certain conditions. What are the certain conditions which are used in order to discovery of electron? First of all, J.J. Thomson here applies high voltage battery, 10,000 volt applies in the discharge tube through cathode or anode and anode. Cathode and anode, these terminals are connected to the battery. Negative terminal is connected to negative terminal, and positive terminal is connected to positive terminal. Here positive represents anode and negative represents cathode. So what are the conditions that are to be required in order to discovery of electron? So first, 10,000 volt energy is applied through battery, and it goes towards cathode. Cathode develops energy, and which gives a type of energy to gaseous atoms which is present in discharge tube. Here ionization takes place, and when ionization takes place, certain types of radiations are to be produced here from cathode which move towards the anode. Certain types of radiations are to be produced from cathode. Those are known as cathode rays, and they falls on this anode tube. Here a type of screen is to be used. That screen is known as ZNS, zinc sulfide. Zinc sulfide screen is used because it has the ability to create, it has the ability to develop glowing. The glowing takes place because of cathode rays are produced from cathode. So what is the condition? How discovery of electron takes place? When 10,000 volt is applied to discharge tube experiment at a normal pressure. So here you should keep in mind normal pressure. At a normal pressure, 10,000 volt is applied to a discharge tube experiment, and there will be no conduction of gases, not showing any kind of change, because the condition is here normal pressure. So at a normal pressure there will be not any kind of conduction, so there will not be any kind of glowing here on the Zardanis screen, so not produce any kind of radiation. So after that, when 10,000 volt is applied to a discharge tube at a condition is here at a low pressure. Condition is at a low pressure, mostly 10 raised power minus 2 atmosphere. 10 raised power minus 2, numerical value of low pressure is 10 raised power minus 2. When low pressure is developed inside the discharge tube experiment and 10,000 volt energy is applied to a discharge tube experiment, then what type of phenomena here takes place? Here phenomena takes place, the gases ought to be ionized, the gases show a type of conduction, the gases show a type of phenomena conduction. And when gases show a type of conduction, certain types of radiations are to be generated from cathode which move towards the anode, and when it moves towards the anode, here is another tube that I have to be defined here at the bottom of discharge tube. This is simply discharge tube experiment, but I have to show here only Zardanis screen. This is Zardanis screen. This is Zardanis screen. Zardanis screen is nothing. It is actually a zinc sulfide, and zinc sulfide is used because certain types of radiation is when falls on Zardanis screen, it shows a type of glowing, and that glowing helps us in order to detect cathode rays. Cathode rays here I will show. These are the cathode rays which are generated from cathode, move towards the anode, and here I will show only Zardanis screen. Zardanis screen, this line that is black line, this is actually Zardanis. Here glowing takes place, and glowing takes place, that is cathode rays are to be falls on Zardanis. So this is the way that how discovery of electron takes place. Now what are the conditions, what are the methods, so that we will see, so that we will observe here cathode rays are to be produced. First of all, J.J. Thomson have used a type of wheel, and that wheel is to be kept inside discharge tube. That wheel is to be kept inside discharge tube, that is paddle wheel. That is paddle wheel. And paddle wheel is to be kept in the discharge tube. When same phenomena is developed, same type of phenomena is created here through discharge tube experiment, then the paddle wheel shows rotation. When paddle wheel shows rotation, it means certain types of radiation which was followed on Zardanis. First of all, attacks on this paddle wheel. First of all, falls on this paddle wheels. Then rotation takes place. When certain types of radiations fall on paddle wheel, a rotation takes place. When a rotation takes place, so this is the first small experiment that is used by J.J. Thomson, and J.J. Thomson then defined a discovery of electrons. These radiations, cathode rays, which falls on this paddle wheel, and then it explains that a certain type of radiation which falls on paddle wheel shows discovery of electron. This is the smallest experiment that is to be discovered in the discharge tube experiment. Second, J.J. Thomson here shows negative palette, and here shows positive plate. When same type of phenomena is generated in the discharge tube experiment, then certain types of radiations which contains negative charge. How it can be defined that there are certain types of radiations which are basically cathode rays contains negative charge, because J.J. Thomson have here defined two plates. One shows negative and another shows positive. When radiations come from the cathode, they deviate towards the positive. They deviate towards the positive. They deviate towards the positive. When they deviate towards the positive, that means negative charge containing negative charge is present in cathode rays, because if they deviate towards the negative, then these rays contain positive charge, but they deviate towards the positive plate, it means cathode rays contains negative charge. So this is the smallest practical that is to be used in the discharge tube. And when discharge tube is used here in order to define what type of charge is present in cathode rays, it means here I will define the cathode rays which come from the cathode which contain a negative charge. Those contain a negative charge because deviation takes place towards the positive plate. So overall, this procedure that I have to be shown through board, a type of diagram, discharge tube experiment. This is first diagram, this is second diagram. Though these two diagrams explain discovery of electron, so how discovery of electron, on certain conditions are to be required. First of all, 10,000 volt and reduced pressure at a low pressure. Normal pressure does not work. Normal pressure, at a normal pressure, and there will be not showing any kind of conduction. The conduction takes place only at a low pressure and 10,000 volt applied energy. So this is the way that discovery of electron takes place. After discovery of electron takes place, we will show some important properties which can be shown by electron. So what type of properties are to be presented, that is to be discussed in the next unit. Okay, thank you. Today this was totally a good, and I think you enjoy here, and by the virtue of this concept, this will be more helpful as that of the other concepts. So thank you.